Circles in the coordinate plane. Here's the definition for you. It's the set of all points, so basically a group of points on a plane, that means a flat surface, not like an airplane. Equidistant, so same distance. You can kind of look at the root word here, distant, and then the prefix equa means equal, so same distance from a given point, which we call the center, which really makes so much sense. So here goes, scrap paper, green pen. If I said, hey, put a dot there, and you put a dot there, and I say, now go 1 inch up, and go 1 inch down, go 1 inch left, go 1 inch right, go diagonal, go. And by the time you're done with this, you're gonna have a circle, hopefully it looks better than that. Now, get used to circles that look like that, because I'm not the best circle drawer, and this set of notes really demonstrates it. So here goes. We're gonna draw a circle with the center at 1, 2. We'll use the same green pen, 1, 2. And it has a radius of 5. So from this center, we're going to go 5 up, 5 down, 5 left, 5 right, 5 this way, 5 that way, 5 this way, 5 that way, 5 to the east, 5 to the west, 5 to the northwest, everywhere. So 1, 2, 3, 4, 5 up. 1, 2, 3, 4, 5 down. 1, 2, 3, 4, 5 right. 1, 2, 3, 4, 5 left. And I'm going to just go ahead and start here and connect those. There we go. There's that. There's that. And if I draw it correctly, which I always struggle with, ooh, that wasn't too bad. A little tragic in places, but if I drew it correctly, then everywhere I drew it, it should be 5 units. Now, it'll be diagonal sometimes, so like this right here, that should be 5. This right here, that should be 5. This right here, that should be 5. Everywhere I drew it should be 5, if I drew it correctly. Don't panic if you didn't. Okay, we're gonna take this idea and make it a little more abstract over here, and we're gonna draw a circle with the center at HK. Doesn't matter where you put HK, I'm gonna put it in the first quadrant. So I'm just gonna plot a point right there, and I'm gonna say, hey, you're H comma K. And then it has a radius of R. So I'm gonna go R up, R down, R left, R right, R diagonally, R to the east, R to the west. Put your left foot in, put your left foot out, put your left foot in, shake it all about. Draw a circle. What's R? I don't care, just be consistent. So I'm gonna let R be this distance right here, which is gonna look a lot like this one. So I'll go the same distance up and the same distance left and the same distance down and the same distance diagonally. Try to draw the best circle you can. Doesn't have to be perfect. But that radius is R. Now, for the sake of the explanation that's about to take place, I recommend that you pick a point somewhere diagonally, preferably there, and draw it. And we're gonna say, you know what? That distance, it's R. All right, that's good to know. Well, that coordinate is an X and a Y, right? So I know I just randomly picked a point and I was like, you know what? I'm gonna pick it here. It could be any X and Y value, so we'll just call this X and Y. Could have drawn it somewhere else, but lucky him, he got picked, right? So I'm gonna also draw the rest of this triangle. What triangle? Glad you asked. Make a little right triangle here. You're gonna see where this is coming from in a second. Right triangle. Now, as I stare at right triangles, there's a lot you can do. You can do trig. You can also use the Pythagorean theorem, which is what we're about to do. Excuse me. So if this distance is R, that's good to know. We'll make it purple now. And this distance is, oh, I don't know this distance. Okay, when you're not gonna know the distance, you're not gonna know the actual number. But here's what you are gonna know. You do know that this point right here, where I'm pointing, has an X value of, no, surprise, X, okay? So X, comma, Y up here. So if I just follow this down, this is also X, comma, something. Actually, it's X, comma, K, in case you care. But this is X, and this is H. So the distance between the two would be X minus H. Okay, well, same idea here. This coordinate right here is X over, and it's Y up. This one's X up, X over and Y up. Well, this coordinate right here is K up. So the distance between these two is going to be Y minus this value, which would be K. So this is Y minus K. Y minus K. All right, so taking this, making some sense out of it, If I looked at that and said, let's go Pythagorean on that thing with this distance, which is x minus h, let's pretend like that was 5 and that was 2. That'd be 5 minus 2, so that'd be 3, right? And then y, and that's k. That y value is k right there. So y minus k would give me y minus k here. If I went Pythagorean on that thing with a blue pen, just for fun, then I would say that a squared plus b squared equals c squared. Ah, okay. Up until this point in your mathematical career, you have learned all kinds of things, none of which you have to write currently, but you've learned things like this, and you've learned things like this. Notice the h and the k, by the way. This is a parabola. Parabola. This is a line. Well, now you know how to graph a circle. This is a circle. And the center of the circle is at HK. So, let's switch to green. I'm having so much fun with these colors. The center is at H comma K, and the radius is R. So in the formula in which we would hand you this and say, now graph this, or hand you a graph and say, what's the equation? The formula is going to have R squared graphed in it. And also keep in mind that if I hand you an H and a K, to put them into the formula, you're going to subtract. Long story short, you're going to change the signs. Okay, we're going to use this in the next few examples.